Hello, I'm Laura Squire, and I'm here today to present how Amazon.com delivers delightful customer experiences using AI and machine learning. Let's start focusing on Amazon's mission to be the world's most customer-centric company. Ultimately, Jeff Bezos, our founder, realized back in 1998 with a letter to our shareholders that our customers are going to be loyal to us until they find somebody else who provides a better service. So Amazon's focus is not to compete on price, but to compete on providing services to customers that delight them. With that, let's take a look at a few of the services Amazon provides that make our customers happy. The first one that I like to think about is our customer promise, Prime One Day or Prime Now. How many of you folks have used that service? I assume a lot of you have. I certainly have. And I was pretty excited when I heard that Prime One Day was available in my area. But what I also was thinking about at the time was what had Amazon needed to do in order to fulfill this promise of being able to deliver a product to me within one day. And so, in my head, I'm thinking, gee, they have to have a lot of vehicles out there that know how to deliver product to my house. They've got to have a lot of product available in the distribution centers so that that product can be delivered. They have to order all of the right things. So I was starting to think about the complex supply chain that Amazon needs to rely on and how demand planning and forecasting is at its core. So if you think about it, at Amazon, they need to forecast 400 million forecasts every day. So essentially, they need to anticipate for every product and every zip code what the anticipated demand might be. And that goes into their ultimate product forecast. But information flows back from that. So if they are going to fulfill product orders, they have to have capacity in their supply chain to be able to provide those orders. And that means they have to have the right staffing available in our fulfillment centers in order to pack the boxes and to get them out to the field. They have to have enough vehicles to go deliver them to the street. They have to have purchased enough of the products that were needed in order to have the products available in the fulfillment centers. They have to place the products in the right locations in those fulfillment centers. And then obviously those orders need to be fulfilled. So Amazon has over 300 fulfillment centers with over 200,000 robots that help with making sure that the right products go from the distribution or fulfillment center to your home when they promised it at the right time. So that accurate delivery promise of one-day delivery really requires a substantial and complex amount of forecasting and planning behind the scenes. And think about it. Last year, we delivered over 1 billion packages to Prime customers. That's a significant promise that we fulfilled. So how does Amazon get it right? How do we know what products to put in the right places at the right time? I mean, how do we know that you're going to order a product even before you order it? Well, let me say, we're not going to know exactly that it's you that's going to order the product, but we're going to anticipate demand signals from the market. And we're going to anticipate those demand signals that are both obvious, such as, we know that demand for things like suntan lotion it's going to go up in the summertime when obviously the sun's out. But we also can anticipate demand for not so obvious products, things like unusual home decor, or, we're going into Halloween season right now. So We can anticipate the demand for a specific type of Halloween costume. How are we able to anticipate those not so obvious products? Well, ultimately, anticipating those not so obvious and even those obvious products relies on forecasting models. So let me just talk a little bit about forecasting. I've been playing around with forecasting for far too long. And I used traditional forecasting methods back in the 1990s, where I actually manually hand-coded rules, where it said, okay, if demand was 42 units last week, demand is going to go up by 0.03 this week. So multiply historical demand by what the demand should be this week, and that's our new forecast. And that's how a lot of companies have been doing forecasts for as long in the past as you can look. But it's ultimately really limited by humans' observation powers. So I can do rough back of the envelope forecast estimates by just multiplying it by an inflator, or looking at, what did we sell last season? How many Halloween costumes were in demand last October? Let's inflate that by a value and use that today. But unfortunately, those traditional methods really didn't learn based on intricate patterns in the data that humans can't observe. And that's ultimately where machine learning comes in. So with machine learning, we're basically going to take the inputs of historical demand, as well as other factors, such as demand of similar products with similar attributes, as well as potentially demographic characteristics of the buying population. And we're going to use that information to build a prediction of demand that not only predicts a value, but also predicts a probability. So now I can say, I think that we're going to sell 100 units of this particular product during Christmas season. And I think that with a probability of 97%. So I can associate a probability with a prediction. I'm just not making a rough guess out of the air based on trends that only I can observe in the data. So ultimately with machine learning, our machine learns, it generates a formula in the data, and that data then can be used for anticipating what the demand for every single product that Amazon sells. So how do we evolve in forecasting at Amazon? I think this is a pretty interesting story. We started out at Amazon doing forecasting using what are known as decision tree methods. And this was around 2007. And with a decision tree, essentially, you put all of the products in a bucket. And then you basically train the tree to try to anticipate what demand is going to be. So a tree may use a prediction at the top, maybe all of my Christmas candies. And then I start, narrowing that down. What was the demand for that product last year, this season? What are the demand for mints? What are the demand for other characteristics of those Christmas candies? And those splits in the tree create buckets, and those buckets create predictions or predicted values. So about 2007, Amazon was using a decision tree method for those predictions. Forecasts with decision trees are going to be better. They're going to add value add to the business beyond, the simple rough human guessing. But today we use what are known as convoluted neural nets. What happens with neural nets is you feed it every potential attribute that you think may be predictive and valuable in anticipating demand for products. And you train that neural net based on the known history of demand for those products. But in between those layers are like the convolutions of your brain, all of those pieces of synapses that interact and have conversations with each other, we can't really tell necessarily exactly the details of how the predictions are made, but essentially all of those attributes interact together to develop a prediction that is highly accurate. And today at Amazon, we train these forecasting models with billions of training points of data. We identify, kind of like the networks in your brain, nonlinear relationships. We automate all of the manual effort that a human might take using traditional statistical or econometric methods for forecasting. And that enables us to be able to build 400 million forecasts for 400 million items every day. So, if you think about it, when it comes to package delivery, how products get packaged and sent out of our fulfillment centers into our homes, it's really a symphony, I love that term, of humans and robots. But essentially, there's a lot of AI and robotics and automation happening to support that effort. So if you look at this picture here, you've got at the bottom these little robots. And these robots have on top of them basically a cubbyhole bin, or I should say a bin filled with cubbyholes where product is stored. As product comes into our fulfillment centers, those products get unpacked and just randomly stowed into these cubbyholes. But we're smart. We're not just randomly stowing them. All of that information is managed by scanning and barcoding and knowing the exact location on the exact robot that that particular product is stored on. And then now we know where all of those products are. We can provide robots to be sent to the pickers at approximately the right time so that the picker can fulfill an order that's been placed. So essentially the picker, as you see this guy here, he is standing in the distribution center. He's working in front of a robot and he's pulling off a product. Once he's selected that product, that item gets scanned and then placed in the bin so that the rest of the automation process for item fulfillment can continue. He's able to visually see and find the products that have been stowed using a bin vision system. And that's the diagram you see to the right where it looks like some of these bins are purple that indicate where the exact packages that he needs to pick up, or I should say the exact products that are in those packages he needs to pick up are stowed. So ultimately, you've got computer vision capabilities, predictive modeling and forecasting capabilities to anticipate where those products should be placed within a distribution center so that an individual can pick them up. And ultimately, it provides a very seamless picking process. And it's rather unique. Most customers that I have worked with in the past have folks that have to go with a pick list through a warehouse to find the products that they need to put in a package to send to a customer. But when you have fulfillment centers the sizes of Amazon, you know, larger than 5 football fields, that poor picker ultimately cannot do that every day, or they'd be running track for a living. So we heard the story of fulfillment centers and meeting the demand of Prime One Day. What are the other things that Amazon is doing to help enhance the customer experience using AI and machine learning? Well, this is a fun one. We're getting ready for the holidays here. And what you see over on the left-hand side are some cookies. And you see some cinnamon in them, And on the right hand side, you see a picture of a kid working on a computer. Well, you know, unfortunately, what we know is that a lot of times, you know, things like cookies and cakes are manufactured in facilities that also manufacture peanut butter. And you might want to put a warning on that label of that product so that that customer who is making that purchase is well aware that the products that they're getting might have, you know, contamination and might enable or cause a peanut allergy. Most of the time, manufacturers are going to label that kind of information, but not always. In the case of things like laptop computers and plugs, there's often we've encountered problems with batteries causing electrical fires. And ultimately, you know, we do need to be aware when there are problem batteries that are going to impact somebody by maybe causing a fire. So what did Amazon do, and what are they doing in order to detect products that we might ship and deliver to customers that could cause a medical outcome that's adverse? Initially, what Amazon did was they put in place a detection program where they collected customer feedback from items and products. They also collected information from regulatory sources. They had a very small team, but basically they watched for that customer feedback to come in. When that customer feedback came in, they investigated those cases of things that cause known medical risks or problems. And if it came up that based on their investigation there was a problem, the item was suppressed and regulatory bodies were advised. Well, what are the limitations of this approach? Well, you can only guess, right? I can only go after and investigate a small fraction of the overall quantity of pieces of information from customer feedback that might indicate a risk that could cause a health problem or a hazard. And so, you know, ultimately the team was not able to keep up with the demand, but they were also backward looking. They were only looking at problems that had feedback associated with them. So the team started saying, hey, what if we can do better here? What if we can anticipate products that might have health risks and instead go, you know, and proactively investigate those particular products rather than coming up later and having to deal with concerns. And so that's exactly what they did. So now what we are able to do is look at billions of products and sales data, hundreds and thousands of concerns annually, and we're able to successfully predict with highly accurate models products that have a high probability of causing some kind of adverse event. And we do that before the product ever goes out the door, before a customer provides any negative feedback at all. With that, let's talk about one final slide or one final scenario where AI ML is being used to provide improved, enhanced customer experiences. And this one, I think, is kind of funny. Back at the beginning of COVID, I don't want to mention how many months we are kind of into it at this point, but back at the beginning of COVID, I remember a news story running on television about what people were doing with their Amazon boxes. People were, you know, making cat houses with them and probably Halloween costumes. Who knows what else they're doing with them. But what Amazon has been doing in the meantime, as part of our pledge to be more environmentally conscious and essentially be a clean company, is that we're focusing on providing shipping that's 75% lighter and takes up 40% less space. I shouldn't say we're focusing on that. Essentially, the shipping that we provide today is 75% lighter and takes up 40% less space during shipping. This has a couple of advantages. First is, unless I'm moving, I don't want another box in my home. I don't think you do either. The second thing is, costs less to ship because you put it in a lighter box, easier for the delivery people to bring that product to you. Takes up less gas because it's lighter. And it also takes up less space, meaning more products can be put on a truck. So essentially, by being able to do a better job with shipping packaging, we're solving both an environmental and a customer experience problem. How are we doing that? Well, we're using, again, some machine learning and AI. Historically, we use some business rules and some visual inspection of products. And historically, what we found was a difficulty in the ability to handle all products that Amazon sells. We also had to manually figure out how to handle non-obvious use cases. So we brought in machine learning to essentially train, based on a product type, what kind of packaging is the most appropriate packaging for that customer and for that type of delivery. And when I say for that type of the delivery, let's just talk a little bit about problem deliveries. Stuff like collectibles. What if I am getting a porcelain doll shipped to me from my grandmother in Kansas? Well, that's a collectible item, and I shouldn't say from my grandmother in Kansas, from a grandmother who produces these in Kansas. That's a collectible item. It's an item that Amazon is selling through their marketplace to me, and I might be concerned that that item is not going to come to me safely. Amazon is actually using specialty models to make determinations of whether the products that are being shipped might be delicate or might need special packaging or handling in order to determine the type of packaging that they use. So in this particular case, we look at the type of packaging, the warranty, the counts, the bag, the shrinkage, all of the elements of that product, whether it's ceramic, glass, stoneware, porcelain, what have you. And we make a determination based on a model of whether that package could be sent in a mailer or not. And if a package does not meet the criteria based on the model for being sent in the mailer, it's sent in a different kind of packing. Makes sense, but it doesn't, in this particular case, require manual intervention to make those decisions. So talk about a little bit of change for Amazon. Today, more than 50% of Amazon's shipments are mailers. And that's pretty important to consider. If you look at the trends over time, in 2016, 69% of all products that we shipped were in big corrugated boxes. If you take a trip to the fulfillment center, Amazon will be sure to tell you that corrugated box is recycled. So it's not as if we're manufacturing net new boxes at an ugly expense to the environment, but ultimately those boxes ended up being delivered on your doorstep for you to have to manage. Today, over 50% of our packages are mailers. And Amazon's now also looking at what we refer to as zero Amazon packaging or frustration-free packaging. So essentially looking at the products and making a determination that some products don't need an Amazon box or mailer for them to be delivered to your doorstep. Saves the environment and also makes me happy because I don't need to break it down any more boxes. So the Amazon team that developed this is able to launch new models within weeks. So very, very quickly, they're able to get these models to market. And they're also able to automate, augment, enrich, and innovate within a few weeks as well. So our Amazon teams are leveraging AI and machine learning, and not only are they getting huge business benefits, but they're also able to turn around these modeling results in days and weeks versus months, which is what historically organizations were encountering. So with that, I'm going to pass this to Chong so that he can talk about what Amazon learned was the most important thing to get right in their AI and ML journey. Thanks.
Hey, thank you so much, Laura. There was a fantastic set of examples that really show how the practical applications of machine learning in the various products and services that Amazon provides to its customers really deliver a delightful experience that really transforms the way that they interact with Amazon and the kind of benefits that Amazon can deliver that really sets Amazon apart from others. And our customers always have a choice to shop anywhere, but they tend to come back to Amazon again and again because of these delightful experiences. So what I wanted to do was to switch gear and actually unpack a few lessons that Amazon has learned in its 15-year journey of applying machine learning in every place that we can find imaginable to drive an incremental set of automations and innovations that really transform customer experiences. And I want to kick off with some examples from outside of Amazon. So what you see here is the results from a recent Gartner survey of top business and technology executives around different organizations. And Gartner asked them, what are some of the biggest blockers that stand in the way of their teams in trying to adapt and apply machine learning in their organizations? And I'll let you take a few moments to kind of read through the results for yourself. And maybe you might find a few things that resonate for you in terms of what your team may be seeing within your organizations. But what the results tell me is this. There's a lot of energy and excitement when a team has an opportunity to learn a new technique or technology like AI/ML and try to find ways to apply that to their customers. But that excitement quickly dissipates when they start to realize that perhaps they get stuck trying to understand where and how they may actually apply that, or they realize that the required skill set just isn't there in the teams, or perhaps the data that they need is all over the organizations and often trapped within the organizational silos, and they're really stuck trying to move forward with the machine learning journey. So let's see how Amazon's insights and lessons learned can help you address some of these blockers. And what Amazon has realized is that there's a lot of many decisions and things that the leaders need to make in order to really guide their teams in the machine learning journey. But these 5 items tend to kind of surface up as the big rock elements that they need to ensure that they get it right and the teams are really enabled to really move forward, because anything here that stands in the way can really throw a wrench into the team's ability to drive machine learning with velocity and build real momentum. And there's a little bit of a sequence of these elements going from left to right. First, you need to align an organization toward a common ambition and a vision toward what the machine learning might look like for their organization. And quickly you define a mission around that and you form a team to start kind of moving forward. And you need to make sure that you're applying the right set of data and equip them with the right set of tooling to start going. And through these efforts, you start to build the capabilities and confidence about the ability to get things right and start building some real momentum and confidence. And the ability to build on that momentum is really the key to accelerating and scaling your machine learning journey in the organization. Now, it's not important to tackle all of these things at once, but it's important to proactively remove the blockers that surface in the journey that slow down your team's progress. And the lessons and insight might be unique to each organization. And while we think that these are some of the key success enablers that we have found at Amazon, we don't necessarily say that these are the best practices or these are the only ways that we do it. I just simply hope to share some insights into the blueprint of how Amazon drives machine learning practices in our organization And I hope that some of these elements are things that you can apply within your organization as well. So let's begin by talking about building the right mindset and culture around machine learning and how it works within Amazon teams. And there are probably many paths to align an organization toward a common mission. And what Amazon has found with its team is that asking the right question is often one of the most simplest and powerful ways for teams to help jumpstart innovation. And this is a question which Amazon asks of every product or service teams as a standard question in our annual strategic planning process. So it's being asked of hundreds and thousands of different teams across all lines of businesses, service, and functions across Amazon. Now, the idea of who is the customer might be different for each team. But what is important is that for the team going through the process of trying to answer this question, they can actually articulate the compelling customer benefits that define success, and then explain how they will deliver that using machine learning. And when the teams wrestled together with this question, Amazon saw several things that really benefit the teams. First is that it brings the domain and technical experts together, because you cannot answer this question simply from a business perspective or purely only from a technical perspective. And it also gives Amazon a basis to set concrete top-down goals and integrate machine learning specific plans against the long-term strategic views and the short-term opportunities within businesses and Amazon customers. And this helps Amazon measure progress and success and enable Amazon to consistently assess progress and pivot quickly where needed. And what I think is really cool about the process is that it's not just the working team that are wrestling with this, but the senior leadership that ask this question and expect to be able to understand the team's articulation of their strategy toward this mission really helps them understand how machine learning really makes a difference within their organization. So they turn them into a even more deeply engaged champions for an organization's machine learning journey. And the good intentions and alignments across the leadership and the working team might get you started. But what Amazon found is that you need to hardwire the right behaviors and effective ways that different roles collaborate and encode this into the way that the teams are organized. So the way that the Amazon teams organize for machine learning success is to bring the technical and business experts together into the product team. So they're not sequestered into their own separate areas, but they're really brought together. And we orient them toward that business problem that we just defined that we will solve for. And what this means is that both teams are now trying to work with who is the customer and how they benefit from machine learning, and work backwards from that to understand the implications into the process, data, and technical aspect of what that solution may entail. And while the practice of bringing business and technology together is not new and is a very common success, recipe for any kind of a technology-enabled innovations, we found this to be non-negotiable for machine learning. Because what happens over time is that because of a unique nature of a machine learning delivery lifecycle, the business person has to really understand how that works so that they can actually work with the teams in a much more efficient way. And for the technical teams to really understand the business and the process and the customers so that as they look into the data and apply the data to the machine to interpret that and then come up with the forecasting models, they are applying a real pragmatic and deep business understanding of it. So what I found really cool is that over time, the lines kind of blur between the two. And sometimes I'm talking to a business leader who talks like a data scientist. And oftentimes I find myself talking to a data scientist who just demonstrates some incredible business acumen in terms of the knowledge of the business. So this is non-negotiable. Now, let's look at kind of different ways that the teams kind of may start and evolve over time. There's no single prescriptive way at Amazon that says every machine learning team shall form like this and then evolve like this. But these are some of the common patterns that I have observed in the different Amazon teams that are using machine learning. So when you first get started, maybe you already have a data engineer who has been supporting the organization with data needs for traditional BI or analytics needs. So you already have some domain experts in terms of data and business, but you may not have a data scientist who's familiar with the latest machine learning techniques or tools to apply to that. So maybe you might find one from outside an organization, maybe it's a consultant or an AWS professional services person. But regardless, many teams start out their journey this way, including some of the teams that Laura has mentioned, the teams that are trying to optimize packaging for Amazon customers or really keep them and protect them and mitigate risk before they happen. They all started out this way, borrowing data scientists from outside the organization. Now, as they find success and usefulness with machine learning and get evidence that this is the mainstream way that they need to do their business and build their services, they quickly now start embedding maybe full-time data scientists into the team, because now they move away from the traditional analytics and methods and fully into machine learning. And there might be organizations where you might have dedicated person or two data scientists within a team, but there are also times where Amazon found that there might be within a function maybe a dozen different teams that need some machine learning, but not enough to dedicate one person. So maybe you have some specialists that are dedicated to the function within a shared pool that support multiple teams, which is the model that you see at the right. So some of the more specialized resources like research scientists who really keep in tune with the latest machine learning techniques and bleeding edge modeling techniques might be useful for many teams, but may not be somebody who's dedicated to a single team. And now you got the team and you got the right roles in place. We want to make sure that they are enabled with the right tools to be successful for the job. And what we firmly believe is that you need to find the right tool for the job. And what you see here is a high-level view of the different stacks of AWS's AI and ML services, starting with some of the AI services at the very top that provide powerful AI and machine learning models that you can apply right away. You can literally plug and play without any machine learning expertise within your organization. And on the other side of the spectrum is what you see in the bottom, which are the expert-grade tools that allow you and give you the flexibility and control at the most granular levels. And this is not for the faint of heart. And these are not where most teams without real deep expertise and experience should start. So the key lesson here is that even though Amazon has been applying machine learning to different areas within its businesses over the past 15 years, there are teams within Amazon that may benefit even more from using some of these simple but powerful AI ML services at the top of the stack. And there are definitely teams that have been at this for over a decade, and they need the ability to tweak things at low-level infrastructure because of the way that they are doing machine learning. So it's not always about going after the most amount of bells and whistles, but it's really a pragmatic assessment of where your team is, what it's trying to achieve within the next 6 months or a year, and what kind of skill set is within the team. And that should be one of the biggest drivers in terms of what tools you think is the right tool for the job. Now, let's talk about data a little bit. And it's a very broad domain, and you probably don't need me to talk to you at length about why this is important. But I do want to share a couple of perspectives that I think would help you think through what you want to solve for as a priority. And what we found at Amazon is that more than 50% of the machine learning team's time, if not more than that for many, is spent in finding, piping, cleaning, and staging data. So a lot of what we call data wrangling needs to happen before the data can even be used toward machine learning and developing the model and testing the model. And this means that there's a lot less time that these scarce and specialized resources are spending on actually innovating versus doing a lot of manual work that we see as undifferentiated heavy lifting. So when Amazon modernized its enterprise data warehouse platform just a few years ago on the data lake that they built on AWS, there are several things that they wanted to get right so that the teams can spend more time innovating and less time wrangling data. And the first thing is that Amazon firmly sees that the teams that are closest to the customers, i.e. at the edge of the Amazon's organizations, away from the headquarters, frankly, are the teams that are in the best position to drive innovations on behalf of the customers with whom they have a very intimate relationship. So Amazon supports this concept of innovation at the edge by providing powerful data sets and flexible toolkits at their disposal in a massively scaled way on its AWS Data Lake enabled enterprise data warehouse. And what this also meant is that Amazon wanted to make sure that those teams are able to dive deep into this data lake, but easily find the exact data they're looking for and bring them onto their choice of data platforms and analytical tools in the simplest possible way for the team. And the way that the Amazon teams are able to search for the data and subscribe to them is quite frankly very similar to the user experience that a typical customer may have on an Amazon.com marketplace. So they want to make sure that the teams are not spending time swimming in the lake versus fish. As soon as they cast the rod into the lake, they find the right data, and the data, when it's delivered, is usable for their needs. So the Amazon data warehouse functions a lot less like a massive collection of data silos, but a rich and active marketplace where data is shared across the enterprise in simple but powerful ways. Now, for most organizations starting out in their machine learning journey, the initial set of investment and the focused effort to get moving can be substantial. And because of that, you need to make sure that you plan your initial machine learning project for success, because that success of the initial project, after all the investment and time, is especially critical. And what we want to make sure, and what we have found, is that it's when that first project that you deliver out of the gate has substance and you have done that with speed, it actually builds the right kind of momentum, excitement around that, so that you can actually build on that and increase speed and move very quickly to realize business value. Now, what you see here is not a set of hard and fast rules or enterprise standards at Amazon, but what we have found to be true or common in most of the situations. Now, the first two are really critical because it's just like buttoning your shirt. If you get the first button wrong, you find yourself very disappointed by the time that you get to the bottom button and you realize that you're on the wrong path altogether. So you want to make sure that where you're trying to apply machine learning is solving real and significant problems for the customer, and it's doing that in a way that we could not have solved for using traditional tools and techniques. And we often believe that if the traditional tools and techniques can get you there 89, 90% of the way, that's probably not where you want to spend significant amount of time with machine learning to unlock that incremental benefit. You want to really find areas where you can really change the game, like what we have done with food and product safety risk, or how we optimize packaging. And we want to make sure that the team is not going to be spending then months and months trying to collect data or find data. We also want to make sure that it's within a domain where we have a reasonable confidence that we have a good set of high quality data that we start tagging right away and start applying toward training your first model. And there is a lot of value in getting to success quickly, but we all want to make sure that the success is not a small proof of concept. And at the end of the day, it might be successful, but we haven't actually proven out that we can do this at a substantial level and really apply this to unlock big business benefits. So there is a bit of a substance along with the speed that is very critical in making sure that all of these click together so that you can deliver something real and substantial within the first 6 to 10 months. And let's talk about scaling just to wrap up. Now, these are some insights from recent Gartner CIO survey that says, in a very optimistic tone, that many organizations are really excited about AI and ML, and they expect to double the number of machine learning projects in the next year. But the right-hand side of this graphic actually tells us the bad news, which is less than half of them expect to actually launch something into production. And what this tells me is that in reality, most organizations struggle to get out of a proof of concept model, or maybe kind of a silo success, and they struggle to really scale these pilot efforts into enterprise-wide production, where it's actually going to unlock customer value and business value. And this limits the ability for the organization to really gain momentum, which can really break a team's kind of spirit when they try to kind of keep applying machine learning and try to unlock real business value. So it is very critical that we pave the way toward scaling as well as getting a team off the ground. Those things are very important. And this is the final concept that I want to cover with you because when you read this graphic counterclockwise, you realize that we already talked about some of the elements around kind of the culture, teams, and how you might actually define success. But as you go kind of counterclockwise and you get to like number 6, what we have found is that because of the unique nature of machine learning delivery lifecycle, a lot of teams are struggling with disjointed tools that they have to kind of cobble together and often piece together with a lot of manual processes in between them. So even though they have a lot of tools at their disposal and they have built some platforms, a lot of these platforms do not actually enable scale. And that is actually not very different for some of the machine learning teams, even at Amazon. So maybe the fact that they have been at this for a long time is a bit of a double-edged sword. So on one hand, there's some incredible depth of expertise, and there's some homegrown machine learning platforms that work quite well. But there's a lot of institutional knowledge and maybe some manual scripts and other things that are hiding behind it that truly hides the cost, and I call this a hidden cost, that actually blocks speed and scale at a certain point. And what we have found is that many teams that are actually using what we call the right tools for the right job are actually able to increase their speed and scale very quickly by getting away from a lot of these kind of manual efforts. So, it's not to say that things that you develop in the house is bad by any means. And at times you have to really kind of configure them and customize them to the way that it works. But we always try to see ways that actually you can apply some of the latest tools, and they're getting just better every year to eliminate undifferentiated heavy lifting for your team. So again, it's not about the best wheels and biggest bells and whistles, but really ways that you say, where is the most of my team's time going? And if it is on things that are about data wrangling and manually handling things that could be easily automated in the latest tools and services that you can use, then it's time to kind of relook at things that you hold dear to your heart and say, this has been the platform that's been driving a lot of success so far, but we need to constantly look for new ways and techniques to simplify and automate. So hopefully that gives you a good sense across what Laura has shared and what I've shared in terms of some of the elements of the blueprint of how Amazon applies a very distinct and a very pragmatic mindset toward machine learning enabled opportunities for our customers and how we organize for innovation around machine learning. So, delivering better services at Amazon, applying AI and ML in every opportunity that we can is not a nice to have, but it's a must have for Amazon. And frankly, that has been the case for a very long time. And that's the only way that we can actually unlock a differentiated level of impact and benefit for our customers that they expect from Amazon. And the system of enablers that I discussed are the big rocks that the senior leaders really need to ensure that they are spending a lot of energy to help remove away from their team's path so the teams can move and build momentum in the machine learning journey. And creating the right way of working, the right teaming model, the right expertise at the right time, and providing them with the right tools for the job is incredibly important so that the teams are not tripping over their own data or tripping over the complexity of the tools, but really able to wield and harness them to build velocity and momentum. And finally, and for some of you, you are there, some of you might just be starting out, but removing the path to blockers to the path to production that often limits the ability for the organization to scale their machine learning enabled innovations across the enterprise is something that you really need to think through in order for you to truly unlock the real business and customer benefits of applying machine learning in your organizations. So I hope that many of the elements and things that we have shared in this session is useful for you as you shape your machine learning strategies and priorities within your organizations. And at AWS, we have many services and offerings and engagement models that we can apply to partner with you side by side to apply what we have learned in our practical experiences within Amazon.com in driving your machine learning success for your customers and for your organization. So thank you very much for your time today.